Hey everyone, and welcome. So, if you're building anything on Amazon Web Services, you're not just writing code. You're basically building a digital kingdom. And just like any kingdom, it needs strong walls and, more importantly, trusted guardians. Let's dive right into the playbook for securing your AWS account, starting from the very first minute. So, let's kick things off with a question. You just created a brand new AWS account. It's clean, it's fresh. What's the single biggest security risk inside it? You might think it's some crazy external threat, but it's not. It's actually something that AWS gives you by default, the very first identity you ever get. And that identity is the AWS account root user. I mean, the name alone sounds pretty important, right? And it is. This user holds the ultimate absolute power over your account, which, ironically, is exactly why we need to talk about it first. Let's just look at the official definition for a second. The key phrase here is complete access to everything. I want you to really think about that for a moment. No restrictions, no limits, no "are you sure" pop-ups. This is the break glass in case of a huge emergency key to your entire kingdom. You can just think of the root user as having God mode privileges. And look, while that's necessary for a few key moments, using an all-powerful account for your day-to-day work, that's like using the master key for every single door in a castle. The front gate, the treasury, everything. One tiny mistake, one compromised password, and the entire kingdom is at risk. It's just not worth it. Now, the crucial point here is that you do need the root user, but only for a tiny handful of really high-stakes tasks. We're talking about things you'll almost never do, like changing your core account settings or recovering a critical encryption key if things go terribly wrong. These are absolutely not your everyday activities. Okay, so if we're not supposed to use the root user for daily work, what's the alternative? Well, you build a team of guardians. And we create these specialized identities using something called AWS Identity and Access Management, or what you'll always hear called IAM. Each one has a specific job and, more importantly, limited power. First up, we've got the IAM user. This is pretty straightforward. It's an identity for a single person, like a developer on your team, or maybe for a specific application. Think of it like giving an employee a key to their own office, but not a key to the entire building. They have exactly the access they need to do their job and absolutely nothing more. Now, imagine having to manage permissions for every single person, one by one. That would get old fast. That's exactly where user groups come in. It's just a collection of your IAM users, so you can grant permissions to the entire developers group or the data analyst group, and boom, anyone you add to that group automatically gets the right access. It's all about working smarter, not harder. And this brings us to one of the most powerful concepts, the IAM role. This one's a little different. A role isn't tied to a specific person. Instead, it's an identity that anyone or any application with the right permissions can temporarily assume to perform a task. It's kind of like a temporary contractor's pass. It grants you access for a very specific job, and then it just expires. And this right here, this is the most important difference between them. An IAM user is tied to long-term credentials, a password, or a set of access keys that just stick around. An IAM role, on the other hand, gives you temporary credentials that expire automatically. And let me tell you, this is a massive security win because it dramatically reduces the risk of stolen keys floating around out there. All right, so we've assembled our team of guardians. We've got users, groups, and roles. But how do we give them their marching orders? How do we define what they're actually allowed to do? Well, that's where we introduce their rulebook. And this rulebook is based on what is probably the single most important concept in all of cloud security, the principle of least privilege. It's so simple, but it's incredibly powerful. All it says is this: don't give a user permission to delete a database if their only job is to read data from it. You grant the absolute bare minimum access they need to get their job done. So how do we actually enforce this principle? We do it with something called IAM policies. A policy is really just a document, written in a format called JSON, that explicitly says what actions are allowed or denied. You can think of it as a legally binding contract for your digital guardians. For instance, just take a look at this policy. It's super simple, but it's powerful. The effect is deny. The action is a star, which just means all possible actions. And the resource is also a star, meaning all possible resources. Put it all together, and this policy denies access to absolutely everything. It's a really effective way to completely block an identity if you ever need to. Okay, now that we understand the team and the rules, let's circle all the way back to that all-powerful root user. It's time to put that thing in a digital vault and, well, pretty much throw away the key. Let me be perfectly clear. This is non-negotiable. The very first thing you should do in any AWS account, I mean it, before you do anything else, is to secure that root user. Don't create access keys for it. Don't use it for daily tasks. Your goal is to lock it down so completely that you basically forget you even have it, until that one super rare emergency. So, how do we build the strongest possible lock for this digital vault? Well, we use the power of two factors of authentication, that is. Enabling multi-factor authentication, or MFA, on your root account is actually surprisingly simple. You'll sign in one last time as the root user, you'll head over to your security credentials, and you'll follow the steps to add an MFA device. What this means is that even if a bad guy somehow steals your password, they still can't get in without also having your physical device. And you've got options here. You can use a physical hardware key, something like a YubiKey that you plug into your USB port. That's the most secure way to go. You could use passkeys that are synced across your devices with a password manager, or you can use a virtual authenticator app on your phone that just generates a new code every 30 seconds. All right, for our final piece of the puzzle, let's revisit that super powerful concept of IAM roles. Because honestly, this is the modern way to manage access securely, especially when you start to scale up. Imagine this scenario. You've got an application running on a server, and it needs to access some files in an S3 bucket. Now, the old way of doing this was to create a permanent access key and just store it on the server. But what happens if that key leaks? The secure, modern way to do this is with a role. So here's how it works. In a nutshell, your application makes a call to a service called the AWS Security Token Service, or STS, and basically says, hey, I'd like to assume this specific role. STS checks to make sure the application is allowed to do that, and if everything checks out, it hands back a set of temporary credentials, an access key, a secret key, and a session token. These credentials work perfectly, but they automatically expire. It's secure, it's automated, and frankly, it's brilliant. So, let's quickly recap the playbook. Number 1, lock down your root user with a strong password and turn on MFA, period. 2, create IAM users for the people on your team and use roles for your applications and automation. 3, live and breathe the principle of least privilege. And finally, number 4, always prefer temporary credentials from roles over those long-term access keys. You know, following these basic rules is like putting a big, strong lock on the main gate of your kingdom. It's the first and most critical step in defending everything you've built. So the only question left is, have you checked your lock recently?